Hey there folks, welcome to the second part of this video where I will be sharing five important differentiation questions for JEE. So in my previous video I have shared these questions and now in this video I'm going to solve it. So coming to the first question, here we are given this 2y equals to this term, and also we are given range of x, and then we need to find dy by dx. So what we will do is, so we are going to give a solution. So what we will do is, we will divide the new in this term, which is 2y equals to cot inverse. So what we are going to do is, so what we are going to do is, first in this term we are going to divide numerator and this numerator and this denominator by cos x. So what we will get is cot inverse root 3 plus tan x upon 1 minus root 3 tan x whole square. And since it looks like our tan property, and this root 3 is tan pi by 3 and this is x, so we will apply since we know this our property as tan a plus b equals to tan a plus tan b upon 1 minus tan a dot tan b. Here we are given like this term, and we can simply derive out this term. So what we will get is 2y equals to cot inverse tan of pi by 3 plus x. Alright, so we also know what is cot. Cot is our pi by 2 minus tan inverse. Cot inverse is equals to, if we can do it as pi by 2 minus tan of inverse tan plus x and whole square. This tan inverse and tan, so this cancels out. What we have is 10 minus tan pi by 3 and minus plus minus x whole square. And so now it is equals to 2y, and then 2y is equals to 3. We will take LCM, and 3 minus 2 equals to pi by 6 minus x whole square. And then we can find our, so what we need to find in this question, we need to find y dash. This is what y dash. Here we have 2y, so we can give our y dash as twice of y dash equals to this comes forward, and this becomes pi by 6 minus x into minus x gets differentiated to minus 1 and cancel 2 by 2, and then we are remaining with x minus pi by 6. So our answer is option number pi by 6. X minus pi by 6. Yes, this one. C. So C is correct answer. Okay. Coming to our next question. Our next question is, so here we are given our f of 1. We are having value of f of 1. We are having value of f dash 1, and we need to find derivative of this term at x equals to 1. So again we'll start our solution. So we will write our given term. What we need to find is what is our f, which we need to find is it is f of plus f of x whole square, and now we will find dy by dx of this term, it will be as dy by dx equals to 1. We will apply our chain rule. First we will differentiate outermost term, which will be f dash of f of x and into f dash f of x into inner term f dash x plus, now we will differentiate our second term, which will be twice of f of x. Now we will differentiate inner term, which will be f dash x. Now we will put at our x equals to 1, we will find out this value. Now what we get is dy by dx equals to, if we put f of 1 into f dash f of 1 into f dash of 1 plus twice of f of 1 into f dash of 1. We are given these values as what? F of 1 equals to 1, f dash 1 equals to 3. So f of 1 equals to 1. Okay, so just stay with me. So f of 1 equals to 1, and then again f of 1 will be equals to 1, and f dash 1 will be equals to what? 3. So this value will become 3 into this value is 1, and this value of dash of 1 will be equals to what? 3. So this value will be 3, and then again f dash 1 will be equals to 3 plus twice into my 1 into my 3. So it will be what? 3 to 27 plus 6 33. So our answer will be option A. Right. Let's move on to our third question. So in our third question, what we are given is x equals to thrice of tan t and y equals to thrice of sec t, and then we need to find value of d2 pi by dx square at t equals to pi by 4. Okay, so just stay with me. So what we know is wait a second. Yeah. Okay, so what we are given is x equals to thrice of tan t and y equals to thrice of sec t. We need to find dy by dx. What we'll do is we will divide numerator and denominator by dt. Okay. So what we will get is, first we will divide, we will differentiate. Now what this says is, we are dividing differentiation of y with respect to t and dividing it with the differentiation of x with respect to t. So what we will get is thrice of t times tan t upon thrice of our differentiation of tan t, it will be 6 square t. And then when I just cancel 3 by 3 sec t by 6 square t. So what I'm doing with is tan t divided by sec t, and which will be my sin t, right? Okay, so now my dy by dx is equals to sin t, and what I needed to find is d2y by dx square. So what I will do is I will again differentiate it. So here like this there is a like plot twist. What I will do is what I will do is for d2y by dx square I can also write it as dy upon dx. Okay, and so it will be d of dx and d equals to cos t times dt by dx equals to cos t into 1 upon thrice of 6 square t, right? And so this will be cos cube t upon 3, right? And then we need to find this value at t equals to pi by 4. So we will put t equals to pi by 4. So this will be so this will be 1 by 3.2 times root 2 or 3 into 2 root 2, which will be 6, 1 by 6 root 2, and it will be our option, last option D, which will be this. Okay, let's move on to our next question, second last question. In this question, what we are given is g is inverse of a function f and f dash x equals to 1 upon 1 plus x to the power 5, and then we need to find g dash x. So you will start from here. What you are having is, okay, so we will start it by fog of x, f of g of x is equals to x, as g is equals to f inverse, and then what we are given is so we will like differentiate it with the help of chain rule. What we will get is f dash of g of x multiplied by g dash x will be equals to 1, and then what we will get is g dash x, which will be equals to 1 upon f dash of g of x, which will be equals to 1 upon, and since we know our f dash x is 1 upon 1 plus x to the power 5, so we will put it as 1 upon 1 plus x, so instead of x what we are having g of x to the power 5, so this will be equals to 1 upon 1 plus g of x to the power 5. So coming to our answer, it is our option D. Right. Coming to our last and final question. In this question, what we need to do is for x in this range 0 to 1 by 4, derivative of this term is root x multiplied by g of x. Then we need to find g of x. Okay, so what we will do is solution. Okay, so y equals to which term? Okay, y is equals to tan of inverse of 6x root x upon 1 minus 9 multiplied by x to the power 3. Okay, so what we will do is first we will multiply this x and root. First we will simplify this term itself. So it will be 6 multiplied 3 by 2 minus 9, and we can also write this x as in same powers. So this can be done as 3 multiplied by x to the power 3 by 2 times whole square like this. Okay. So what I will do is now I can see this as, since we know a property of tan inverse, which is twice of tan inverse of x is equals to tan inverse 2x 1 minus x square. So I will use this property and then I will derive I will just simplify this term. So what it will be twice of tan inverse thrice into x to the power 3 by 2, which will be y, and then what I will do is I will find my y dash, right? Yeah. Okay, yeah. We are also given like derivative now, so we will find y dash only. Yeah. So it will be as twice into 1 upon 1 plus 3x 3 by 2 square multiplied by chain rule 3 into 3 by 2 into x to the power 1 by 2. This 2 cancels this 2, and then what we are remaining is with 9 times root x upon 1 plus 9x to the power 3, right? Because this square cancels this 1 by 2, and we are remaining with x cube. Yeah. Okay, so our y dash is this, and what we're given is like root x times g of x. So upon comparing this to root x dot g of x, if I cancel this root x, then my g of x is 9 upon 1 plus 9x to the power 3. Okay, so this is my option A. Okay, so now we are done with all the 5 questions, and so hey there folks, these are like 5 important questions which I felt that I should share with you all guys, and see you in the next video. Thanks.